Number 25, write the equation of the graph function. So these folks are absolute value functions, so they come in the template where your slope is right there, the slope of the right arm. I call this the right arm. Whoa. And you have x minus some h value plus some k value outside of the absolute value brackets. And so what to remember is, again, this m is the slope of the right arm slope. And your vertex is going to be at h comma k, which means because there's a negative sign in front of the h, it's the opposite of whatever you see there, and then literally whatever k is. So let's identify our vertex. Our vertex is at -3 comma -7. What is it, -3? It's -4. Sorry. -4 comma -7. So that means I'm going to leave a space here for the slope. We're going to have x, not -4, but x plus 4, because it's the opposite of whatever the x vertex actually is. And then outside of that, -7. You literally take the y value and you put that, including the symbol, outside of it. Now let's find the slope. The slope looks like it's up 1 and right 2. And again, I'm doing the right arm. So it's a positive 1/2, rise over run. And there is our equation of this absolute value function. Let's try it again. Our slope here is 3 comma 0. Sorry, not our slope, our vertex. Excuse me, vertex is right there. Slope is just 1, up 1, right 1, up 1, right 1, of the right arm. So you could put 1 in for the slope. Then it's going to be x minus our x with the opposite of the vertex x value. So this is a positive 3, so we're going to actually have a -3 there. And then you could write down plus a 0, because your y coordinate is a 0. Now, this is a multiple choice test. What your final is, you're not going to actually see this answer there. This multiplier of 1 out in front, we actually don't have to write a 1 there. And then this y value of 0, we don't actually have to, the plus 0 at the end is kind of silly to actually write down. So this is your final answer, your best answer right there. Name the vertex of this function. So again, it's the opposite of whatever is getting done to the x there, opposite, and then it is this. So it's positive 1 comma -3. How many solutions does this given system have? Show your work. So you're going to solve each of these things for y. Each of these equations for y, excuse me. So we're going to subtract off the x, divide by -3. So you get y equals x over 3 plus -4/3. Why you're doing that, folks, is if lines have the same slope, that means that they either never touch, or if they have the same slope and they have the same y-intercept, then that means they actually touch all the time. It's like that yucky couple in the hallway. I'm just kidding, but PDA is yucky. Anyway, that was inappropriate. Sorry, bad joke. So let's see if the slopes are the same, and if they are the same, then we have to think about, are they touching forever because their y-intercepts are the same, or are they never touching, their y-intercepts are different? Well, you know what, folks? Their slopes are not the same. So how many solutions do they have? Because their slopes are not the same, they will intersect at some point, at some time. So there is one solution. Number 29. Solve each system of equations. What is the x value of the solution? Show your work. So I'd say solve the systems of equations. I don't like that. Solve the system of equations. And when you're solving, you're supposed to get an x and a y. So anywho, I like to use substitution here when they're not both in standard form. So that means that x, whenever you see an x, that's equivalent to 4y minus 1. So I see an x in this other equation. So instead of writing down x in this other bottom equation, I'm going to write down 4y minus 1. Make sure you put parentheses in it. And I just keep on writing down the bottom equation. So we got to distribute. oops, distribute, so we get negative 12y plus 3. Careful on that one. Oh, well, they ask you what the x is because it's easier to get the y. We're solving for y right now. So we get negative 10y plus 3 equals negative 7. You subtract 3, you get negative 10y equals a negative 10. So that means that y equals 1, folks. But again, we're not done. We need to figure out what x is. Well, if you use this top equation now, notice if you just plug in 1 for y, you can quickly see what x equals. X is going to equal 4 times, again, 1 minus 1, which equals 3. So x is going to equal 3. Number 30, graph the systems of equations. So take this one at a time. Here my y-intercept is negative 2, and my slope is negative 1. So negative 2. And this is going to be a solid line, by the way, folks. So we're going down one, right one, down one, right one. Whoa. Now when it's in slope-intercept form, if it's eating the y value, it means that you're shading above the line. The y or the heights have to be greater than the line. This is where the y's are greater than, or the height is greater than the line. Shade above. If that shortcut helps you, use it. Whereas this one, it's in slope-intercept form, and y is less than the line, so you're going to shade below. I'm going to do this in a different color. So here, it's going to be a dashed line because there is no equivalency underneath the inequality. So y-intercept is 4, slope is 1. So do use your points, and then just do the best to kind of just dash through that. And then again, I'm shading below the dashed line. So I'm going to just lightly shade here, but really this part's not part of my solution because this is a system of inequalities. So the solution is, where does it satisfy both inequalities? So you're looking for the plaid. You're looking for the red and the blue. So this region below the dashed blue line and on the red line or to the right or above it is the solution to the system of inequalities.